So what tomorrow's lab involves is calorimetry. It's actually a Hess's law application of calorimetry, but we don't have to worry about Hess's law. We'll talk about that. That's near the end of chapter 7. But in calorimetry, we're going to use a calorimeter. A calorimeter is like this heat measuring device. And so normally when we do look at our system, our system's either going to gain heat or energy from the surroundings, or it's going to lose heat or energy to the surroundings. Now the surroundings is very complicated because the surroundings consist of the rest of the universe. And so if you think about the rest of the universe, there's just too much there to deal with. And so to simplify, where the heat comes from or where the heat goes, we use a calorimeter. And so here, if we look at our system, let's say our system absorbs energy from the surroundings. So heat is entering from the surroundings into the system. So here the system is gaining energy. And we want to figure out how much heat left the surroundings into the system. We can use a calorimeter to do that. And so in this case, the surroundings here would be heat measuring device would be one way of putting it. One way of looking at the surroundings, well, the surroundings must have lost energy. And so in this case, the system's gaining, the surroundings is losing. Now, what is losing in the surroundings? Well, what's losing energy in the surroundings is the rest of the universe, but we try to keep it simple. And so we just say that the calorimeter, maybe this is getting too crowded in here, the calorimeter or the calorimeter and some other stuff is supplying the heat to the system. Likewise, if the system is losing energy here, so this, where does that energy go? Well, it's going to go into the rest of the universe. The rest of the universe is the surroundings, but that makes things complicated. If we want to keep track of this heat, then what we should do is we should dump the heat into the calorimeter and other stuff. And so we'll just have a calorimeter as our surroundings. Calorimeter. It might be the calorimeter alone, or it could be the calorimeter plus other components. And the other components, we know well what they are, and we can figure out, how much heat each of those components do absorb. And so calorimeter plus other stuff. And so the calorimeter is going to be, pretty much our surroundings in this case. And it's going to just be controlled surroundings rather than, the entire universe. We try to confine the heat to a small part of that. And so typically calorimeters are kind of insulated, so not too much heat disperses out, but it's not a totally isolated system because in an isolated system, the heat can't escape. Well, calorimeters, they aren't going to stay hot forever. Right? And eventually heat's going to dissipate into the rest of the world. So let's look at two basic designs of the calorimeter. It depends on our system, Well, what types of systems do we deal with? We deal with constant volume and constant pressure. Since we deal with those two types of systems, there are two types of calorimeters. There's the constant volume calorimeter and a constant pressure calorimeter. And so the first one we're going to look at is the constant volume calorimeter. The constant volume calorimeter is called a bomb calorimeter. Decent pens here. Bomb calorimeter. And in order to maintain constant volume, it's got to be strong, right? Let me do this.